Hello, my name is Greg Smoczyk, and I'm the GIS program manager on the Chequamegon-Nicolet National Forest. With Mark Farina, who's our forest soil scientist, we both work out of the forest supervisor's office in Rhinelander, Wisconsin. Today, we'll be sharing about our forest participation in some data acquisition efforts. We'll also outline how this data helps us accomplish our mission in more efficient ways. Mark, the floor is yours.
Thanks, Greg. To start, I wanted to highlight some collaborative data acquisitions. The Chequamegon-Nicolet has participated and contributed in three data partnerships towards LiDAR acquisition for numerous counties in northern Wisconsin. Most recently, we have partnered up with the acquisition of Ashland in Florence County. I believe that has been flown. We haven't seen the data yet, or at least I haven't. But that is something that's new for us. We were able to get funding at the regional level to acquire data at the QL1 level for the national forest portions. I believe that was a 3-county acquisition. We have a significant amount of land in 2 of the counties for Ashland and Florence. So this will be a little bit different in that it's that QL1, which is, I believe, 8 pulses per meter return. All of our data is leaf off spring flights. In addition to those, we partnered up with Forest County. That was signed in 2016, flown in 17. Price County, that was flown in 18. Sawyer County, flown in 17, and Taylor County, flown in 16. In addition to the LiDAR partnerships, we also have historically and continue to contribute funds for the W-Rock imagery. We just signed a agreement last fall for 6-inch multi-band imagery. I believe that's a statewide flight. We're still waiting on that data currently. Go ahead, Greg.
Next, we'll outline some specific projects where acquired LiDAR and imagery have allowed for great advancements in efficiency on our forest. The first such project is the Watershed Improvement Inventory project. So this project uses LiDAR to aid identification of watershed impairment sites like old roads, railroad grades, dams, and erosion sites within streams and wetlands. The hillshade allows for identification of places that haven't been accessed by anyone in decades, if ever. There's a tremendous time savings to our watershed program for their specialists to complete their work. This also provides the ability to find great watershed restoration projects on our forest. The image seen here is a planned dam removal that was much more easily identified by LiDAR hillshade. Another program on our forest that is finding excellent value in LiDAR-based derivatives is our engineering group. In the past, tedious site inspections were necessary at many of the ongoing improvement projects on the forest. This involved high costs as man hours and travel time contributed largely to our overhead. Over the last couple of years, our engineering group has increasingly been leveraging products like detailed contours that are derived from LiDAR DEMs to do this site work remotely. Engineers are finding that this data can replace many of the components of an on-site visit. This has directly led to large cost savings on many of these improvement projects. And you can see in the image here on the left, some detailed 1-foot contours that were developed from LiDAR DEMs. And then these contours coming into CAD to develop road gradients. Mark?
Okay, the next one I'd like to highlight is improvements to our NHD streams layer. And last year, the region came to our forest and talked about potentially doing a pilot project through GTAC, which is our, Greg, you might want to help me out. I think GTAC would be described as our like national I don't know, they're like our geospatial experts in remote sensing.
Geospatial technical resources for the entire Forest Service.
Yep. So they approached us about picking out a watershed and just kind of seeing what we can do for improving our stream placement. And so we started that last year, and they basically did took the LiDAR, the QL2 LiDAR. This was in, I believe, Forest County. And they used basically the ArcHydro environment in kind of a, I don't know what the word is, but a sort of like a proprietary methodology where they basically take the LiDAR and determine the flow direction and then the flow accumulation. And then they go through a process of stream definition and segmentation to arrive at the final stream placement. But the most important thing, the key to it, is kind of figuring out the sensitivity of the model for the landscape, and that's where we came in. So myself and the hydrologist took several of these models out into the field this summer, and to determine, you know, what's the correct sensitivity was for that particular watershed. And before I describe the two slides a little bit more detail, I'll just say that it's important to us because inaccurate stream and drainage spatial data during the planning and our NEPA process results in huge inefficiencies during the implementation phase, especially when it comes to permitting, you know, during or right at the beginning of a timber harvest. I mean, it also obviously is important for just general overall resource, water, wetland protection. So the slide on the left is what we basically took out in the field, and it shows the different sensitivities, which essentially shows basically how far up a hill and into the uplands the model will call something a stream. And the picture on the right, I'm not sure if you'll be able to see it. Unfortunately, it's not very clear. But what it shows is the old NHD layer and the placement of the new one. So at any rate, we determined what the proper sensitivity of the model is, and we're just currently waiting for it to be redone by GTAC, and then we'll take it out to the field one more time. And so far, everything indicates that this is going to be an excellent process and will probably be how NHD data will be redone in the future. Go ahead, Greg.
Another project that has seen great benefit from LiDAR acquisition and imagery acquisition was the 2019 Blowdown event on the eastern side of our forest. In July of 2019, The eastern side of the forest experienced a catastrophic windstorm that led to extensive damage to forest resources. This damage affected existing timber stands, roads and trails, and also recreation site functionality. LiDAR products were leveraged extensively in the effort to recover from this event as quickly as possible. Forest employees went to work quickly on creating timber salvage sales, fixing recreation sites, and reopening roads and trails. Much of this work hinged on the acquisition of recent satellite imagery and LiDAR data to identify areas of concern and calculate damage states. The map on the right in this slide illustrates the level of damage in the Blowdown area.
Okay, the next project I got here is another pilot that we started last year. And this occurs on the Rat River watershed, and it's collaboration with the state for updating the Wisconsin wetland inventory. We've always had, I guess, issues with our wetlands layer, and it's, you know, very important to us to have an accurate wetlands layer. It's something that we use all the way from the planning and NEPA process all the way up to implementation of state BMPs and forest plan guidelines. And we do a significant amount of monitoring every year, both state and federal monitoring on the protection of wetlands. So it's extremely important to us, and it has been one of the most important, things we've asked for really for probably decades. But at any rate, they're using LiDAR slope, and they're basically looking at slope inflection points as well as imagery to better define where these wetlands occur. To my understanding, it's like a combination of manual interpretation of the LiDAR models as well as a semi-automatically automated detecting using these inflection points. The state is actually pushing all the buttons on making the models. I've seen the results. I haven't seen the process in detail. But what I can say is some of the areas that they've worked in, the data looks excellent. So in that picture, again, it's really small. I'm not sure if you'll be able to see, but that top row on the left would be the old wetlands mapping. The next one would be the modern data using their workflow. And they're not only better defined, like the edges of the wetlands, but where they had point data before, now has smaller, more accurately delineated polygons. So that's what I got, Greg. Next. Okay, so the next generation soil initiative, this is another project that I'm actually involved in. And this is occurring on the Argonne-Drumlin LTA up in our Eagle River Florence district. And it's a collaborative with the Ottawa National Forest and the Natural Resources Conservation Service as a part of their digital soil mapping initiative, which is essentially the next generation soil survey. So the results of this will actually update the National Cooperative Soil Survey data layer. And they're using LiDAR to create raster-based, high-quality soil maps. And what they're doing is they're taking these different derivatives in a raster environment that are important to that particular landscape. And then they're combining them all to produce one map based on soil properties, and then kind of boiling that into a improved soil map. So the image on the left shows in a drumlin field the depth to restrictions. So that would be like a color ramp signifying depth to a fragipan or dense till in our area. The map in the middle shows a color ramp showing soil organic matter. And the one on the right, which I believe is probably going to be the most important to really full use and management for forestry is a wetness index. So on that, you can see the black lines are traditional soil polygons, which would describe essentially one soil. The wetness index, or rather an index based on soil. Begin to really see, we can really begin to break up that polygon and interpret uses for forestry management. For instance, ratings for rutting or ratings for soil compaction, or even taking it one step further, we're able to break up that soil polygon into different areas and potentially, well, not potentially, we will be able to make the best determination on what time of the season we should be harvesting timber. Okay, next.
Overall, LiDAR and imagery product acquisitions are playing a key role in the advancement of our forest GIS goals and capabilities. Smaller projects like annual map updates to motor vehicle use maps and recreation maps are increasingly incorporating this data. Programs like engineering, archaeology, and watershed are now able to identify areas of need for ongoing projects. We will continue to pursue participation in these data acquisitions in upcoming years. Over the next year, we'll be receiving a NATE product derivative that will allow us to better model canopy height for areas around our forests. This will have a positive effect on numerous forest programs as well. With that, I just want to take the time to say thank you for giving us the opportunity to present today. We're looking forward to more in-person collaboration in the future. Until then, though, please feel free to reach out to us virtually. Our email addresses are listed in the slide. Thank you.